So in this video I'll be doing problem 65. 65 says, an object is undergoing simple harmonic motion with period 1.2 seconds and amplitude 0.6 meters. At t equals 0, the object is at x equals 0 and is moving in the negative x direction. How far is the object from the equilibrium position when t equals 0.48 seconds? So first of all, we want to know the phase angle because it's going in the negative x direction when t equals 0. And as we know, velocity equals negative WA sine of omega t plus the phase angle. And sine of 0 is 0, so it can't be moving at when t equals 0 unless there's a phase angle. So we ignore this, and since we know it's negative, we can set sine of, we know t equals 0, so we just have sine of theta, and for velocity, and we set that equal to 1. And then we do inverse sine of 1 equals the angle, and inverse sine of 1 equals 1.571, which equals pi over 2. So then we know that the phase angle is pi over 2. So then next we want to know what omega is. So we use our period equation of t equals 2 pi over omega. And it tells us that the period is 1.2 seconds. So we do 1.2 equals 2 pi over omega. Multiply omega up. So then we have 1.2 omega equals 2 pi. And then we divide by 1.2. And we get omega equals 5.236. And we know the amplitude. It tells us the amplitude is 0.6 meters. So then we go to our position equation, which is x equals a cosine, or amplitude cosine of omega t plus theta, and we plug in everything we know, these three numbers. So then we have x equals 0.6 cosine of 5.236 t plus pi over 2. So then we want to find out what t is, or we want to find out what x is. To tell us what t is, we want to know how far it is from the equilibrium position at t equals 0.48. So then we'll have x equals 0.6 cosine of 5.236 times 0.48 plus pi over 2. So then when you multiply these two numbers and add it to pi over 2, and then whatever number you get from multiplying these and adding that to pi over 2, you do cosine of that number and multiply that to 0.6. And what you'll end up with is negative 0.353 meters. And that is the answer to problem 65.